Well, hello, wonderful Algebra 2 students. Okay, so this is actually take 3. This morning, I made a video right after my morning class because we had such a great discussion about some of the prior ideas. We didn't get to the practice problems for today, 504. But the problem was I was on the wrong screen, so you didn't see any of the work I did, but that's all right. We all make mistakes. We notice them, we fix them, and we get right back on it, okay? So now it's pretty good. This is pretty encouraging that those of you who have taken it are doing pretty well. Wonderful. Again, I am always here. I love teaching you. You have an interesting curriculum. You have a different situation than in a traditional brick and mortar class, right? You have your asynchronous learning. So for those of you using that, excellent. For those of you who like these videos, excellent. For those of you who like Class Connects, excellent. Help Labs, wonderful. Okay? So whatever works for you. I think that's an amazing part of this high school is you really get to, as I'm going to quote Mr. Spurlock, you get to learn how you learn. So I thought that was a wonderful observation, and I think it's very true. Learn how you learn best and learn. That's all that matters. And then after high school, after you're done being forced to learn these ideas that we think are valuable, and I think they are too, just to expose you to them. Afterwards, you choose. You choose what you learn. You pursue your passions. So, great job. Let's go get into these probabilities. There were some great points I made in those last videos. I don't remember them. I do apologize for that. Some of the key things I want to talk about, though, are how to read probabilities, how to write probabilities, how to put them into the formula. So we're going to talk about that. That's going to be my goal for this video. A and B are two events. The notation for conditional probability is read. It is read the probability of B, given, that's what that line means, A. Okay? One of the big story ideas is that sometimes we're given probabilities, probability of rolling a 3 and then rolling a 6, and they don't change each other. That probability doesn't change. It's going to be the same. The probability of rolling a 3, we've talked about this in class, you've talked about it in the homework, 1 in 6, because there's on a dice 1, 2, 3, 4, 5, 6, one of each number, 1 out of 6 chance. When you roll, every time you roll, it's independent. The prior roll does not affect the probability of rolling that number the next roll. It becomes the same. It resets. It's like replacing that option every single time. It is independent. Okay? So the probability of rolling a 3, given that you just rolled a 3, is going to be just the probability of rolling a 3, 1 in 6. It doesn't matter what you rolled before because it's independent. Not independent are things that affect the probability of the next event. Okay? In class, in your online lesson, it talked about an airplane, right? One of my classes, we didn't get to it, and one we did. An airplane, an airline is flying, and what is the probability that it arrives on time? That initial probability, the way that's found is all the planes that left, and then on the top, the numerator is all the planes that arrived on time. Okay, so that's that first probability. But now the next scenario is what is the probability a plane lands on time given that it left on time? That changes something. That is a dependent. It is not independent. It is conditional on the second or the first thing happening. So the first thing that happened was it left on time. So now what is the probability that it'll arrive on time given it left on time? Keep thinking about that, and we're going to get here to the notation. But that's what this is saying. A and B are two events. The notation for conditional probability for this version, it's read, what is the probability of B happening given that A has happened, or we know it's to be true? What we talked about in class and in your lesson, well, if it was independent, it would just be the probability of B. That's that dice. the probabilities are independent. It doesn't matter. They're always just going to be those probabilities. Okay? But we know it's not dependent. I mean, it's not independent. Oh, I'm so sorry. I keep saying that wrong. It is conditional. It is dependent. It's being changed. Something is happening. So this is the math, the probability math for that. When it is not independent, meaning the outcome is affected, the probability of B given A can be found if we know the probability of A and B happening, A and B happening, over the probability of the given. So notationally, this might change, and it does change on this quiz in different problems, right? Sometimes we'll read it the probability of A given B, right? This given would be the denominator. The given, when we read it, is the denominator for this math. Denominator. Okay? So in our case, our given is A. Does that make sense? Remember, we're reading notation, we're reading probability, we're reading our mathematical hieroglyphics. The probability that B happens given A happens can be calculated, can be found if we know the probability of A and B divided by the probability of A. So that's what we're looking for. This isn't true, right? But this is the notation that we're looking for right here. So the first set of questions, and we're going to talk about all of them because of the notation, how important it is. So if you have variation 2, probabilities A and B are two events, the notation for conditional probability is the probability of B given A, which statement is true about conditional probability. So these you're now going to check for what the words say, which confused me too in our first video that you'll never see because I had to delete it because you couldn't see anyway. You just heard me rambling. No idea what I was talking about. Okay, I paused it for a second because I'm a little bit confused. I'm pretty sure I'm sharing this screen and I'm concerned that I might not be. But that's this, I double checked this time. Oh boy, here's hoping it's the correct screen. What are the probability that I'm not? There are two options when I clicked record. So it's 50-50 chance. And right now it's very confusing to me. This has never happened before because all right. I might just finish question 1 and then make a second video because I want to make sure that I'm sharing the correct screen and there's no way for me to confirm. I paused it for a second to see if there's a way for me to say, this is the screen you are sharing. So, let me see this. Nope, there's no way for me to verify. All right, so question 1, here we go. A and B are two events. The notation for conditional probability is the probability of B given A, what will be true? So notation, definitions. Okay, so first of all, we don't have anything in this form that we're learning about. So whenever you see something that we're not learning about right now, you can kind of throw it out. Does that make sense? The probability of B divided by the probability of A. So the conditional probability of B, this doesn't make any sense. This doesn't make any sense. These two we have talked about. One has to do with an independent, and one has to do with one that's not independent. So we need that correct. Let's take a look at why is this one right. The conditional probability of event B given event A is the probability of B given A. This is an accurate formula. This is an accurate formula. Okay, see how it's the probability of B given A equal to the probability of B, the first part of the notation. This would be true if it was independent. So the reason we don't pick this one is because it says it's not independent. This is true if it is independent. If that not wasn't there, this one would be true. But that not is there If it's not independent, meaning it is dependent, right? This is the correct notation. So since they both had not independent, this is what it will be if it's not independent. This is what it will be if it is independent, right? Thinking of our dice rolls, they don't matter, they don't affect each other, versus the airline, right? If we know we left on time, doesn't it make sense that the odds, the probability that we'll arrive on time is going to be higher? If we don't know, we just, right? So that's what the conditional probabilities are about. They're affected, they're changed, versus independent, doesn't matter. Me rolling this dice, I got a 2. And me flipping this coin, I got tails. Independent events. The dice does not affect the coin. Anyway, keep thinking about those ideas. Question 3. A and B are 2 events. The notation for conditional probability is said, again, P, the probability of B, given that A has happened. Which notation is the probability of 2 events being independent? Independent. We just did it with the coin and the dice. Okay. Key things to note about this notation. The probability they're asking for, like the first probability, the event B in the notation, that has to be the final probability. This will be confusing. They've written this, the probability of B given A, and they write this, the probability equals the probability of just A. This is not the same statement. This is not true. This doesn't imply independence, This implies independence because they're asking what is the probability of B given A? Well, if we're given A, but the final outcome is still whatever the regular probability of getting B is, right? I'm going to flip this. Boop. I got a heads this time. Does that mean I'm going to not roll a 2? Oh, well, I rolled a 1. But no, they don't affect each other. So the probability that I will roll a 2, given I flipped a heads, is still just the probability I'll roll a 2. It doesn't matter. The probability I roll a 2 doesn't matter if I'm given, I flipped a heads again. I'm hoping that's kind of making sense. However, that is not the same statement if the final outcome, and it could be mathematically, it doesn't imply independence. So notice notationally, independence, the first probability being asked, is the final probability when you do the math. Not the same thing as if we ask what is the probability of B given A has happened. If it's equal to the probability that A happens, does not imply independence. So that's the notation. Pay attention, pay attention, pay attention. Okay? All right, I'm going to stop recording on this. Some final thoughts. Independent, right? Doesn't matter what A is. We'll just still get the same probability. Dependent. Not independent. It matters. It changes things. The given probability is in the denominator. The B, like not given as in here's what it is. Given as in what is the probability of B given A has happened. So the given that the event has happened probability is in the denominator. The probability that both have happened is in the numerator. This is for not independent events, dependent events. Okay? You can still do this math. Absolutely, you can do this math. And some of the problems you'll see, you'll end up doing this math and it'll spit out the probability. That's fine. That just means you can say, oh, if that happens, if we have the probability of A and B divided by the probability of just A, and it equals the probability of just B, then they're independent. That's all that means. Okay, so we're just going to be dividing. We're going to be looking for those relationships, and we're going to be trying to make sure we set up the probabilities correctly. This is video 1 for quiz 504, notation, conditional probabilities, how to read it, how to write it, what you're looking for, those small keywords, not independent, independent, discerning between the two of them, knowing what they mean, and then also being able to click the right ones, okay? So thanks for watching this first video. I'm going to stop, make sure I'm sharing the right screen. 50-50 chance. and then you'll see the second video.